Algebra 2 video project by Natasha, Novak, and Alyson, Youngpeter.
For our video project, our topic is solving problems involving variation. The SOL number is A11.10, and the description is that the student will identify, create, and solve real-world problems involving inverse variations, joint variations, and a combination of direct and inverse variations. For our hook, we said that direct variations occurs when one variable increases and the other variable also increases. Inverse variation occurs when one variable increases while the other decreases, and joint variations is when one variable increases and the other variable also increases. Along with the hook, we have pictures explaining each variation. For inverse, we have a seesaw because one person is down while the other is up. We have direct variation because the plane is up as well as the passengers, and then joint variation is when 3 people are up.
Our ways to remember are, you can remember direct variation by its definition going straight to the point because both variables go in the same direction, either increasing or decreasing. You can remember inverse variation by its definition opposite or contrary in position, direction, order, or effect because in an inverse variation problem, the variable goes opposite way. Variable increasing while the other is decreasing and vice versa. You can remember joint variation because the variables are jointly increasing or decreasing. The student goal is to find the constant of proportionality involving a combination of direct and inverse variations. Problem. If y varies directly with the square of x and inversely with the cube root of t, what is the constant of proportionality if x equals 4, y equals 3, and t equals 8? The formula for direct variation is y equals kx. The formula for inverse variation is y equals k divided by x. The formula for joint variation is y equals kxz. First step is to determine the types, orders, and variations.
Step 2. Plug in variables x, y, and t. Again, x equals 4, y equals 3, and t equals 8. 3 equals k times 4 to the second divided by the cubed root of 8. Step 3. Solve equation for x. 3 equals k times 16 divided by 2. We found the square of 4 and the cube root of 8. 3 equals 8k. We divided 16 and 2. K equals 3 over 8. Divide 8 to both sides. That's the final solution. An alternate to step 3 is to solve equation for x, where 3 equals k times 16 divided by 2. We found the square root of 4 and the cube root of 8. So 6 equals k times 16 when you cross multiply. The final solution is k equals 3 divided by 8. We divide 16 and 6 and simplified.
Problem is finding the constant of proportionality in solving real-world problems, including a combination of direct and inverse variations. The problem is, assume that the wind resistance varies jointly as the object's surface area and velocity. If a ball of a surface area of 25 square feet traveling at a velocity of 40 miles per hour experiences a wind resistance of 225 newtons, what velocity must a ball with 40 square feet of a surface area have in order to experience a wind resistance of 270 newtons? Our first step is to determine the types and orders of variations. Assume that the wind resistance varies jointly as an object's surface area and velocity. Y equals kxc. Step 2. Plug in the variables. Y, wind resistance, x, surface area, and z, velocity. If a ball with a surface area of 25 square feet traveling at a velocity of 40 miles per hour experiences a wind resistance of 225 newtons, 225 equals k times 25 times 40. Step 3. Solve the equation for k. So what you do is you put 225, you plug in the numbers into the solution, which is right there, and then so you multiply 40 times 25, which equals 1,000, and then you divide 1,000 by 225, which equals 0.225. For step 4, solve for the velocity. The equation is r equals 0.225 times A times V. What velocity must a ball with 40 square feet of surface area have in order to experience a wind resistance of 270 newtons? What you do is you put 270 equals 0.225 times 40 times velocity. What you're trying to do is solve for velocity. So you multiply 0.225 times 40, which equals 9. Then you divide by 9, which equals V equals 30.